Clarity is a digital supply chain finance platform engineered to close this gap. It operates as a unified marketplace connecting three verified actors: the supplier who needs cash, the buyer who owes it, and a funder looking for yield. Funders deploy immediate capital, buying the invoice at a discount, allowing suppliers to access up to 97% of funds within 72 hours. Compressing a 90-day wait into a 3-day payout requires a specific system architecture. The platform must instantly and accurately value the financial risk of a deferred payment. The primary barrier to operating this marketplace at scale is volume. Human underwriters cannot manually evaluate the risk of thousands of daily invoices. The system requires a deterministic algorithm to instantly assign an exact financial cost to the likelihood of a buyer defaulting. This function is handled by Clarity's custom risk-based pricing engine. This chart maps the platform architecture. The engine acts as an active choke point. It intercepts data flow, calculating the discount rate before any external action occurs. It also enforces strict credit limits, querying the database to ensure a buyer hasn't exceeded their capacity before allowing ledger updates. The engine calculates and immutably records the exact supplier payout amount before a single dollar of capital is allowed to move. Building a multi-tenant financial marketplace requires taking abstract credit risk and translating it into hard, unchangeable database states. The database lifecycle begins when a supplier uploads a raw PDF or photo of an invoice. The system's optical character recognition extracts the buyer name, invoice number, amount, and due date, logging the record as submitted. At this stage, the pricing engine cannot execute. The debt is entirely unverified. The corporate buyer must log into their portal, review the extracted data, and apply a digital signature. This confirms they actually owe the money, creating an immutable legal obligation. This database table visualizes the exact transition. Upon signature, the status column updates from submitted to buyer confirmed. The system utilizes a guarded state machine. This specific buyer confirmed status is the strict required prerequisite for an invoice to become eligible for funding. This exact state change also fires a system trigger, analyzing the buyer's history to generate a baseline A, B, or C risk rating. Without this legal confirmation gate, any algorithmic risk math would be calculating the value of a potentially fake liability. Once the liability is verified, the internal pricing math begins by evaluating the buyer's credit score. This visual breakdown details the core algorithm, starting with PD, the probability of default. The engine maps the credit score to a specific default percentage. To prevent extreme outliers from breaking the pricing, the system constrains this number between hard-coded floors and ceilings. Next, it introduces the LGD, or loss given default. Multiplying the probability of default by the expected loss yields the actual risk premium. The system then takes the base cost of capital and adds that calculated risk premium. Finally, it adds the platform's operational margin, typically 0.5% to 1%, to generate the total annual rate. This deterministic formula fully removes human bias, deriving the underwriting cost entirely from predefined logic. But an annual rate evaluates risk over a 12-month period. Supply chain invoices typically mature in 90 days. The engine must apply tenor proration to adjust the rate to fit the exact timeline of the debt. This diagram illustrates the discount calculator logic, which scales the annual rate down to match the invoice's actual duration. The system pulls the exact number of days between the current date and the maturity date, generating an integer to complete the calculation. This exact chronological precision dictates the final amount the supplier will receive if they choose to finance early. The output is a hard, risk-adjusted dollar value locked into the database as the payout amount. For the supplier, this prorated integer is a guaranteed cash metric they can use to accurately forecast their payroll and procurement. Once the invoice is priced, it hits the marketplace. Now the server architecture must execute the transaction safely. Funding can be initiated manually by a user clicking a button or instantly triggered by a funder's automated investment rules. In a high-speed environment, the primary engineering risk is two funders attempting to finance the exact same invoice at the exact same millisecond. To solve this concurrency problem, the system executes a database row-level lock. The very first request claims the row, instantly blocking all subsequent attempts. While the row is locked, a secondary query rapidly checks the buyer's active credit limit to ensure this specific transaction won't breach their cap. If the limit holds, the system writes the winning funder's ID to the row, permanently establishing ownership. The final commit writes the payout, updates the internal wallet balances, and shifts the status to funded. It is this precise sequence of API checks and database locks that physically protects the deployed capital. 90 days later, the invoice reaches its maturity date, moving into the final state machine stage. The buyer clears their liability by transferring the full face value into their platform wallet. This flowchart visualizes the settlement waterfall engine, managing how repayment is distributed. First, it processes the principal. The exact amount the funder deployed is routed back. The remainder represents profit. The platform deducts its fixed fee, and the rest is routed to the funder as realized return. At this exact moment of settlement, the theoretical risk premium calculated by the engine 3 months earlier is realized as actual cash yield. Operating at scale, thousands of invoices run through this exact life cycle. An unverified PDF is confirmed as a legal liability, then priced mathematically, locked securely, and finally settled as a reliable asset.